So for this subject, first we need to know what we call definition of evolutionary computation. What does it mean, evolutionary computation? So evolutionary computation is an abstraction from the biological evolution. Okay, biological evolution that is used to create optimization procedure. Okay, so based on the theory of biological evolution, we copy the idea of the biological evolution. So we propose optimization technique or algorithm. So for optimization, we have many techniques. So one technique, for example, for optimization, genetic algorithm. Okay. And then this optimization theory implemented to solve the problem. For example, problem like a TSP, traveling salesman problem, or problem for how to manage the timetable, for example. So we can use the optimization approach. Evolutionary computing is an exciting development in computer science, and it's amount to building, applying, and studying algorithm based on Darwinian principle of natural selection. Natural selection means we have a process like a crossover, mutation, for example, crossover, mutation, and then we evaluate the fitness function. Okay, this is the process of natural selection. Okay, evolutionary computing, EC stand for evolutionary computing. Based on biological inspiration. Okay, biological inspiration. For example, using Darwinian theory. Okay, we simplified to based on this theory. So we introduce the genetic algorithm. Okay, genetic algorithm. So what can EC do? Okay, so evolutionary computing can do, for example, can manage or can generate the timetabling, for example, for student or for lecturer, for nurse, doctor, and so on. So we can use the EC technique to produce the good timetable. Okay, or we can use or we can, for another example, for example, like a delivery system. Okay, delivery system. For example, how to manage the item. Okay, for example, Shopee or Lazada. So we also can use optimization to manage the item, how to distribute the item, So also we can use GA. Okay, another example, for example, traveling salesman person. So we can use GA also, or ACO, PSO, and so on. Okay. Okay. Consider this figure. The left side, this is biological what we call representation. For example, based on environment. This is sorry, not biological. This is what we call the how do we represent the problem. Okay. For example, first we need to know the real problem. We need to understand. We call environment. Okay, like a problem. So we need to we need to explore, or we need to know every single problem, or in detail about the problem. Okay, so based on that problem that we study, so we need to construct the mathematical formula. We call fitness function. Okay, and then for each, what we call, based on the mathematical formula, we need to evaluate. We need to evaluate the best value for that certain problem. So we call individual. Okay, individual. So certain, for example, for genetic algorithm, we set 10
Sorry, sir.
Yeah.
Ada ramai yang nak masuk.
Oh, okay. Yes. Dah, semua dah. Sekejap. Okay. So based on this, what we call, I repeat. So for example, if we have problem, so problem like student timetabling, for example, how to manage the schedule for student timetabling class, for example. So we need to know the detail about problem. For example, number of student, number of subject, for example, and then number of number of subject, classroom, and so on. So based on that what we call that variable involved, so we need to represent using mathematical formula. Okay. So based on that mathematical or we call fitness function or mathematical formula, so the best what we call the best result, mean, okay, based on the mathematical formula, how to evaluate the mathematical formula? So we need to generate the chromosome, for example. So one chromosome considered as one individual, one candidate, one chromosome. Okay, so that chromosome will evaluate the fitness function or solution quality. So the best solution quality is the best what we call the best output lah. So we discuss in detail after this. The fitness is chances for survival and reproduction, and quality the chance for seeding the new solution. Okay, because every candidate have different quality. Some candidate number 1 maybe the quality 80%. Candidate number 2 maybe 90%. Candidate number 3 maybe 50%. So the best candidate is the highest value, the best candidate. And then the best candidate we pick up, and then we put as what we call as parent. Okay, parent for reproduction. Okay, the history of optimization started year 1948 Turing test, proposed genetical or evolution search, and so on. This is what we call the history of optimization. So you can go through on your own. Okay. And then evolutionary computing in the 21st century, like this. This is the what we call the conference or the journal that we have today. Very uncountable application. and so on. Okay, Darwinian evolution 1, survival of the fittest. Mean all environment have finite resources. Okay, mean can only support a limited number of individual. For example, limited individual, we need to define the number of individual. For example, we define 50 individual or 60 individual or 20 individual. So what happen if we set the what we call the individual is big? What happen? So the system will calculate more actually if we put individual higher. But if we put individual lesser, for example, just 10 or 20, so the burden of compute the process, computing the process is what we call smaller lah, faster. Okay, faster. But actually have pro and con actually. So we discuss in detail after this. And then this is the evolution. Okay, phenotype. What does mean phenotype? Phenotype mean the dah nak masuk sekejap. Phenotype means the behavior of physical differences that affect response to environment. Okay, then partly determined by inherent partly by factor during development and unique to each individual, and partly as a result of random changes. And then phenotype also lead to new combination of trait. Okay. Okay, I give you one example like this. Sekejap. Sekejap. Okay. Macam ni. Okay, consider this, what we call this biological chromosome. Okay. Okay, this is the biological chromosome. Sekejap. Okay, like this. Macam mana nak cerita the population? Population consists of diverse set of individual. For example, before we start our process of optimization, we need to define the number of population. Consists of set of individual. So sometimes we define number of population 50 or 100 or 10. Okay. So for example, 10 population. So 10 population mean the population like this. This is the one sample of chromosome. Okay, this is the second chromosome, third chromosome. So the inside of the chromosome, actually we have the DNA lah, different the DNA. Okay, so for 10 chromosome, we need to draw 10 chromosome like this. So now just 4, 5, 6, and 7. But for 100, so we need to produce 100 chromosome. Okay, this is
Sorry
called,
sir,
yeah.
Sir share screen yang mana? Tak nampak macam dia
Tak
kat slide.
nampak Oh,
Ha.
okay. Tak nampak. Sekejap.
Tak nampak slide.
Okay, nampak? Nampak tak?
Nampak sir.
Okay. Okay, I repeat. For example, the population consists of set of individual like this. For example, for 10 individual mean 10 chromosome lah. Chromosome mean for chromosome we can draw like this. This is one chromosome, second chromosome, third chromosome, and so on. So for 10, so we need to draw 10 figure like this. Okay, for 100, so you need to draw 100. So the DNA for each chromosome represent by like this lah. This is the DNA, the code or the information. So we can keep inside this column kat sini. Column. And then combination of traits that are better adapted tend to increase representation in population. Mean individual are unit of selection. So each chromosome or individual have what we call quality. Okay, quality. So chromosome number 1 may be better than chromosome number 2. How to measure the quality? Quality 1, quality chromosome number 2, quality chromosome number 3. So we can measure by using fitness function. So, for example, we have 10 chromosome, 1, 2, 3, 4, 5, and 10. So we need to evaluate every single chromosome. Quality for chromosome number 1, quality chromosome number 2, till quality chromosome number 10. So after that, we do comparison. For example, chromosome number 3 and chromosome number 5 is the best. 5 and number 3 and number 5 chromosome, the highest value compared to 1, 2, 7, and so on. So we choose this chromosome and we put this chromosome as a what we call parent to reproduce another chromosome. We do the crossover here after this and so on. That the main idea for Darwinian evolution. Clear? Tak? Tak
Clear,
clear?
sir.
Clear, sir.
Clear kan? Senang je. Okay, natural genetic jadi biological process. The information required to build living organism is coded in DNA that organism. Genotype mean DNA inside. Genotype is mean DNA inside, mean determine the phenotype. Phenotype mean chromosome. Genotype mean DNA inside. Okay. So in biological, this thing we call phenotype, but the inside of phenotype we call genotype. And then the small changes in the genotype lead to small changes in the organism. For example, the color of skin and so on. Genes are encoded in strand of DNA called chromosome, as we discussed just now. And then in most cells, there are 2 copies of each chromosome deployed, and the complete genetic material in an individual genotype is called genome. Within a species, most of the genetic material is the same. Okay, this is the example of human DNA. Okay, I think no need to, you can go through on your own. The biological process. Okay. Ini the fertilization, human fertilization, for example, mother and father can get the new person lah, or zygote. Okay. Can go through on your own lah. Okay, so genotype, the combination of genotype can produce phenotype, but phenotype cannot produce the genotype. Okay, this one also you can go through on your own. Mutation. Okay, what does it mean mutation? For evolutionary computing. Mutation like this. Mutation, for example, we have chromosome like this. The chromosome like this. And then for this chromosome, we have a value for each sector. For example, value 1, 0, 1, 1, 1, 0, 1, 0, for example. So after we mutate, for example, maybe we can mutate 5%. Okay, so 5% maybe based for this case, maybe just one sector je lah we mutate. So after we do the mutation, 2, 8, katalah 8, 2. Okay, so we mutate, so we copy from previous chromosome, we copy, then we mutate. Mutate mean we just flip 1, 1, 1, 1, 1, 0, 1, 0. So we just flip. We just change this column je, this value. So this is what called mutation. Mutation. So by random actually. Random. We just put a value, for example, 5% of mutation or 10%. Kalau 5%, for example, for this case, kan, katalah this one we have 8 sector, so 5 over 100 multiplied 8, so equal to berapa? 40, 100. 4, 10 equal to 0.4. 0.4 we just equal to 1 sector je lah. 1 ataupun tak ada. not more than one flip. Clear? Clear ke tak?
Yes, sir.
Clear, sir.
Just 5%. How about 20%? So 20% of mutation, so 20 over 100 multiply 8. 8 sector ni. 1, 5, 8/5 equivalent to 2. So 2 flip lah. 2 sector need to ni lah. So kalau 2 maybe column number 4, so this one change to 0 lah. Macam tu. That one for mutation. Okay, developing, analyzing, applying, problem solving method. Okay. So for example, we have problem. So that, for example, we have many problem. So for example, problem like for example, to determine apa? Never mind. No idea sekejap. Sekarang blank. Okay, tengok kat sini. Okay, consider this term. Time for truly problem analysis decrease mean the complexity okay, take a break to 2 minutes. I ada something to manage. Sekejap 2 minit. Take a break.
Okay, sir.
And that means he's instantly taken down. Scout now stepping in. Dipping, ducking, diving. Abidagi laying down a little bit of damage. Ignite's being traded back and forth, leaping in. Stolen Ignite as well, but Scout.
They're coming.
I'm so dead.
No, you got this. You got this. Fuck him up.
Wait, no ulti, Gragas. No ulti.
Gragas,
No ulti, Gragas.
But they have people.
Oh.
It's okay.
Oh.
No ulti pike.
Oh.
Not a bad start for me, honestly. Not getting cheese or anything like that. I'm saving my smite just in case I do get cheese. That's not good.
Okay, kita continue. Boleh?
Boleh, sir.
Okay.
What is it?
So motivation for evolutionary computing part 2. So developing, analyzing, and applying problem solving method is a central theme in mathematical and computer science. For example, for delivery system using optimization. So first we need to know the we call the problem, and then after we know the problem, we need to analyze the problem, Okay, we need to know the process from A to Z, the process of delivering system, and then after we analyze, we need to we need to generate or propose the mathematical or fitness function of the problem, of that problem, and then after we propose, or after we construct the mathematical formula, we need to suggest the method that we want to use. For example, maybe we prefer GA, for example, or ACO, PSO, okay, Firefly. And then after we decide the technique that we want to use, so we need to develop the system. So developing system depend on us lah, the programming tools and so on. And then after we develop, we apply the system to organization. Then time for true problem analysis decrease and complexity of problem to be solved increase. So we need to robust problem solving technology. Okay, because of time decrease and complexity increase. So we should have one technique or one technology or one algorithm that can solve that problem or robust problem solving. So one of the best solution using optimization technique, for example, GA or PSO or ACO and so on. Okay, like this, we have consider this figure. We have a model for our system and seek input that give us a specific goal. For example, input like a delivery system. So we need to know the scope, okay, the project scope, and then the model. Model mean which technique that we want to use, and then the output the result lah. The best what we call the best solution. So input and output. For this case, for example, timetable for university, call center, hospital, delivery system, or traveling salesman person, and so on. Okay, boleh faham? Tak boleh? You want ask something? Ada? Tak ada?
Clear, saya clear.
Sir, yang model tu maksudnya jenis-jenis algoritma ke?
Ya, algorithm. Model. Model mean under this model, we need to define here ni this model. First, we need to the model lah, jap. The model under this thing, we need to do the analysis of the problem. Then, based on this analysis, we need to construct mathematical formula of fitness function. And then under this model also, this construct under this model also, we need to propose the method or algorithm, the method of optimization. For example, GA, ACO. Maksudnya we need to propose or we need to pick up one technique, then we implement ACO, PSO, and so on. GA, and then develop Then after develop, just run, then we have output or result. Clear?
Okay, clear. Thank you, sir.
For example, timetabling. Timetabling involve a big search space. Yeah. Enormously big search space. Why we put here big search space? What does it mean? Ni kat sini. What does it mean? Search space. I'll give you one example. Okay, you know the factorial calculation. For example, we have 7 factorial. 7 factorial mean 7 multiply 6 multiply 5 multiply 4 multiply 3 2 1 equal to more than 1,000 solution. So for example, if you have 7 class, 7 classes or group, so how many what we call for example, if you have 7 group of 7 classes lah, 7 classes and number of subject maybe 6 subject, and then apa lagi lecturers tak apalah, subject and okay 7 classes and 6 subjects. So based on this what we call this variable ni, how many what we call how many different timetable that we can produce. Actually 100 of different timetable that we can produce. That's why we call enormously big search space. And then each timetable that we produce have different quality. Different quality mean maybe timetable number 1 clash to another subject. Timetable number 2 clash another class, and so on. So that's the quality is if clash, the quality is drop. If not good lah. So that's why we need to evaluate for timetabling ni. The good quality mean no clash. The timetable ni, no clash. So we discuss in detail after this. Okay, like this. For university timetabling. Okay, the progress is 55% of quality, maybe. Okay, this is what we call the rough idea of timetabling interface. Okay, modeling. Okay, modeling example, loan application credibility, fitness, function, model accuracy on historical data. Okay, this difficult to explain, difficult to what we call to ni, because involve many the variable that involve I don't know how to for the ni lah for the bank loan, okay, loan application. So maybe the variable involved, maybe the commitment, for example, commitment, and then another example, another variable involved, maybe apa lagi, the occupation, lagi the age, and so on. Okay. So based on this variable, we construct mathematical formula. So to construct mathematical formula, very difficult actually, very difficult mathematical formula. And then based on the mathematical formula, we evaluate by chromosome. Then each chromosome have quality. So the best quality mean the best chromosome. Okay. So detail after this. Okay, ada soalan? Go through the ni. Ada soalan? We discuss, tak ada? We proceed. Ada ke tak? First class selalu blur, don't worry. Bila nak masuk third lecture and so on, I think more better lah, more clear. Okay, we proceed to part 2. Okay, jap, I nak cari yang magic square punya demonstration kejap. I want to show you the how to ni. Kat dalam slide ni tak ada. Jap, I nak cari. Dalam slide yang satu lagi kot. Main tak ada. Tak jumpa cari. Okay. Saya nak you all Okay, consider this thing, for example. Consider this thing. Traveling salesman problem. Just problem. Okay. For example, this salesman need to visit the cities. For example, we have three cities. Three cities: A, B, and C. The distance from A to B maybe 100 kilometers, B to C 200, for example, and C to A 300. Okay, so the salesman can start at any node or any cities. Maybe you can start at C. From C, go to B, and go to A. Occur only once. Occur only once. From C, can go to A, and after that go to B. And then from B, can start from at B. B, go to A, and go to C. B, can go to C, and after that A. For A, can go to C, can go to B. A also can go to B, can go to C. Okay, clear? Okay, so this what we call this list of road have different quality. For example, from CBA, C go to B, go to A, equivalent to 300. Kalau CAB, CAB 400. Clear? Kalau BAC, BAC 400. Kalau BCA, BCA, BCA is 500. ACA, ACB, what about A, C and B? 500. Kalau ABC, 300. Mean the mathematical expression or formulation, summation of xi equal to fx. So mean the minimum, because the distance, we need to define the shortest path, okay? The shortest path. For this case, the best chromosome, for example, if we draw CBA, chromosome, this one 300. Kalau CAB, this chromosome equivalent to 400. So mean based on this mathematical formula fitness function, 300 better than 400 because we consider minimum, the shortest path for traveling. Okay, boleh faham ke? Hello, senyap ni?
Boleh sir.
Boleh kan?
Boleh sir.
Jadi then CBA better than CAB. So for this case, for the list of chromosome the best chromosome, chromosome number 1 and chromosome number last. Mean the best quality lah compared to others, compared to other chromosome. Tapi kalau we put here maximum, max, mean maximum the best quality is this one. Depend on mathematical. That's why I said mathematical formula or mathematical expression is very important. How we define the problem. How we define the problem. Then that one you imagine for 3 cities, how about 5 cities? 5 cities. Kalau for 3 cities mean 3 factorial. 3 factorial mean 3 multiply 2 multiply 1 equal to 6. Tengok 6 different road. Tengok sini. Kalau 5 mean 5 factorial. 5 factorial 5 multiply 4 multiply 3 multiply 2 multiply 1 equal to 20, 150, 150 to 300 solution or 300 what we call chromosome that we should consider. How about 10 cities? 10 cities. 10 cities mean 10 factorial. 10 factorial mean 10 multiply 9 multiply 8 multiply 7 and so on mean millions. Million solution of chromosome that we need to evaluate. Sekejap, ada orang nak masuk ke? Clear?
Please.
Yes, sir.
Ni kalau yang baru masuk ni nanti pening nanti nak faham ni. Kena masuk awal. Jadi okay, now we proceed to part 2. Part 2. Okay, now introduction to evolutionary algorithm. Now, before this, EC. Now, EA. EA is part of EC. Okay. Okay, EA is a subset of evolutionary computing, generic population based on materialistic optimization algorithm. And EA uses mechanism inspired by biological evolution, such as reproduction, motivation, and so on, mutation, and so on. And then after that, candidate determined by fitness function, the quality of solution, and so on. Okay, EA is a heuristic-based approach to solving problem that cannot be easily solved by polynomial time. Okay, what does it mean heuristic-based approach? Ni kat sini. Siapa boleh explain heuristic-based? What does it mean? Siapa tahu? Pernah dengar ke perkataan heuristic? Pernah dengar ke tak?
Pernah.
Tapi tak tahu. Tapi tak tahu apa benda. Tak tahu maksud heuristic. Tahu ke tak?
Tak sangat.
Tak sangat. Yang tak sangat tu apa yang you sangat tahu apa? Yang sikit tahu apa? Just
heuristic is like a gut feeling.
Gut feeling. Gut feeling actually not sure. Yeah, I'm not sure actually.
I mean it's more or less like
memory macam tu kan.
Rule of thumb.
Rule of thumb. What does it mean rule of thumb? Okay, I'll give you one example like this. Okay, for like a TSP, just now we discussed, for 3 factorial equivalent to 6 solution. 6 solution, okay, we still can manage to evaluate every solution, so easy to manage because just 6 solution. 6 solution, so mean we calculate, then we show the result. For 5 factorial, for example, 5 cities, so maybe 300 solution, 300 solution. So still can manage this one. But how about 10 factorial or 10 cities? This is million solution, million. So million difficult to manage because to produce the result need time, maybe 2-3 minutes, maybe more than 5 minutes to calculate, then show the result. So because of time is constraint here, so we need to produce, or we need to introduce the heuristic base, okay, that's why I said time of what? For example kan, macam ni. For example, if we have million of solution, okay, for example 1 million, for example, solution. So this is not practical to evaluate every single solution. It's not practical. So how to solve this problem? So we introduce the heuristic
Base.
technique. Heuristic technique mean we pick up, maybe we set 1,000 solution from 1 million solution, or subset of solution, then we evaluate for 1,000 solution. So this process we call heuristic. Clear?
It's like a short-term solution then.
Yeah, short-term, but acceptable solution lah. Not short-term, but short-term but acceptable solution.
Alright, sir.
Saya macam kurang jelas lagi.
Okay, like this. For example, katalah we have solution 5 million solution. 5 million solution. So to evaluate every single solution need time. This is not practical to evaluate every single solution because maybe 2-3 minutes, more than 5 minutes is not practical. Betul tak? Kalau 5 million solution,
Betul lah, dia ambil masa lama.
takes time. Maybe 10 minutes or maybe half an hour baru dapat result. So that not practical. So how to solve this problem? So we propose heuristic base. Heuristic base ni we just pick up subset of 5,000 solution. How to pick up? We using GA, ACO, PSO, and so on. That's why we say we call GA is a heuristic technique or heuristic search technique, GA. Betul kan? Heuristic GA. Yeah, because for 5 million solution, we cannot evaluate all the solution. We need to consider the practical solution, how to solve this problem. So that's why we introduce heuristic method or approach. And then for heuristic approach, this is under GA using heuristic approach also, ACO, PSO, and so on.
Jadi macam heuristic base ni basically dia macam solution boleh terima lah.
Yeah. Rule
dalam
of
banyak-banyak tu, walaupun ada yang lagi perfect tapi kita ambil astagfirullahaladzim.
That's why you tengok katalah you just consider 1,000 solutions only from 5 million solution. So 1,000 maybe the best bukan the good, the best result or the best solution maybe not under this solution, maybe dekat luar So
Oh.
mungkin dekat yang 5009000. Mungkin dekat sini. But this one just can produce a good solution lah, not worst solution. The best solution under the 5 million solution. Good solution. That's
Untuk
why
save time lah kan?
Yeah, that's why every single that's why for genetic algorithm, first we need to we need to set number of population. Maybe you set 1,000 solution, number of population. So mean you set for the first time 1,000 solution for first iteration, and then the second iteration after you evaluate 1,000, you need to run for another iteration, and then another iteration you can pick up from 5 million ni. Faham tak?
Faham.
You pick up from 5 million solution, then from first iteration dengan second iteration you do the comparison solution. Contohnya solution at iteration number 1 better than solution at iteration number 2. So iteration number 2 you just remove, you just consider iteration number 1. That's why we keep updating the result till the result is perfect. Faham tak?
Faham lagi kot.
Okay.
So nak tanya, kalau fitness function untuk yang semua ACO tu semua dia tetap sama je kan? Dia punya mathematical.
Yeah, mathematical fitness function same untuk GA, PSO, SO, but the process how to calculate different. The mathematical is the same, using the same mathematical formula, but the process how to evaluate the what we call the chromosome is different.
Okay. Thank you, sir.
Okay. So ada lagi soalan? And then apa lagi? Evolutionary algorithm are heuristic-based approach to solving problem that cannot be easily solved in polynomial time. Okay, such as classical NP-hard problem. And then anything else that would take far too long to exhaustively process when used on their own. Okay, nothing. Okay, I show you the algorithm for basic algorithm for EA. So first we begin, we set the population. Okay, initialize the population with random candidate solution. So for example, for 5 million solution, we just pick up randomly the candidate solution. Randomly. For example, you set 1,000 solution, so the population randomly pick up from 5 million solution. Just randomly pick up. And then after the population, we need to evaluate each candidate or each chromosome. how to evaluate? Based on mathematical formulation or fitness function. Okay, the what we call the quality of chromosome tu. And then after we evaluate, we need to repeat. We need to repeat until the condition is satisfied. For example, repeat mean the number of iteration. For first iteration, you need to do all these things. This is the select, recombine or crossover, mutate, evaluate, and select. This is first iteration. And then after you evaluate, you have a result lah. Okay, so you keep the result. For the second iteration, you follow the same process, then you can get another result. So another result. So result 1, result 2. Result 2 for iteration number 2. Then you can do the comparison lah. Which one is the best? Okay, for result number 1, for example, if you have 1,000, after you evaluate 1,000 solution, so you pick up amount ni lah, yang 1,000 ni maybe you pick up 2, the best yang from 1,000 solution ni, you pick up 2 solution. So you can put this solution ni, yang 2 solution ni, put as a parent, then you do the recombine or crossover. Crossover. So can get the what we call the children, and then the children you evaluate again the result and so on. So after you evaluate, you need to select balik, and that we call the iteration number 1, iteration number 2, and so on. So this is the process of the simple process of EA. Ada soalan?
Tak ada, sir.
Okay. Tengok ni. This is the flow chart of EA. Okay, stopping criteria is satisfied mean stopping criteria of number of iteration. For example, if you set number of iteration 100, so you need to run 100 times. Kalau you set number of iteration 1,000, so you need to repeat 1,000 process for same process. Mean the stopping criteria ni. Kalau you stop, yes, mean reach 1,000 iteration, so stop and give the result lah. Report mean show the result. Detail we discuss later. This is the rough idea. Okay, you nak stop kat sini ke nak proceed? I takut you tak boleh nak follow je. Boleh follow lagi ke? Atau dah stop? Dah.
Tengah proses tapi boleh follow lagi sekut.
Okay. Yang lain? Boleh follow? Atau nak stop dulu?
InsyaAllah boleh.
Stop dulu saya.
Tengah digest.
Digest, okay. I give you 5 minutes to digest. Okay, go through. You all make sure attendant, please tick attendant. Jangan lupa. Okay, so consider, boleh follow? Boleh sambung, continue? Can we continue? Okay.
Boleh sir.
Okay, consider this figure ni. Okay, based on this, what we call this flowchart, so we can draw the figure like this. Population, for example, we have 10 solution. 10 solution mean we have 10 chromosome lah. 10 chromosome like this. 10 lah. 10. So after we draw the ni, and then the solution we evaluate. So maybe solution number 3 and number 4 is the best. So we select as what we call as a parent selection. Okay, solution 3 and 4 ni, chromosome 3 and 4, based on 3 and 4, based on ni, the 10 solution ni. So 3 and 4 is the best, so we select 3 and 4. So we put as a parent. So parent ni, solution 3 and 4, so the solution like this, 3 and 4. After we put 3 and 4 as a parent, we do the crossover or recombination. Crossover, for example, crossover like this and crossover. For example, 1 0 0 0 dengan 0 1 1 1. So after crossover, maybe crossover at point number 2. Okay, contoh. Crossover at point number 2 kat sini. So 1 0 1 1. And then satu lagi 0 1 0 0. This is the what we call the offspring. Clear? Ulang. offspring or children ni. For example like this. Tak nampak, takut tak nampak. I ulang. Katalah the best solution like this, chromosome number 3 and chromosome number 4. Chromosome number 4. Okay. Recombination or crossover. So produce a children like this. At point number 2 point number 2 kat sini. Point number 2. 1 0. Ambil yang kat sini pula 1 1 1 1. Kalau yang satu lagi 0 1 0 1 0 0. Clear?
So, saya soalan.
Yeah.
Each chromosome tu, the number of segments are always even I mean 8 ke, it's not ganjil so that we can.
No, that depend on your number of variable. Okay, for example, your variable have 8 atau 20 variable. So you should draw 20 sector ni, 20 column.
So even number lah kan? Even number of variable.
Tak semestinya.
Tak semestinya. Okay.
Okay, that one for point number 1. What happened for point number 2? Point number 2 kat sini, for example. Point number 1. That one, this result at point number 2. Crossover at point number 1. The children look like this. Point number 1, 1, 1, 1, 1. 1, 1, 1. 2, 4. 2, 4 ni tak ada. And then, satu lagi. 0, 0, 0, 0, 0. Children. So ni the worst lah. Worst quality. Sebab 0, 0, 0, no value. At point number 1. At point number 2, the result look like this. Point number 1, look like this. Clear?
Clear, thank you, sir.
Yeah.
Okay, so I think I want to stop today. I nak discuss about project pula. Okay, so that's all for today. So now we proceed to project. I nak explain about project sikit. Okay, boleh? Then we continue next week for the next slide ni. Next week lah. Okay, for our project, so you need to propose the title. Title of your project by week 3. I nak tengok week 3 dah ada title together with the synopsis. And then this number 1, number 2, number of student for one group between 5 to 7. Okay, student, and then Number 3, kalau boleh you include the related article also that you refer. Article or journal that you refer ni, related article or journal. Okay, you need to include. Your format. First, title. Second, the introduction. Third is a literature review. That's all. Boleh? Boleh ke tak?
Boleh.
Boleh kan? Then you need to submit lah. Kalau tak sempat literature review, introduction or synopsis lah. Tapi kalau boleh yang ni LR ada lagi bagus. Okay, lepas tu number 4, propose the tool that you want to use, programming language, for example. Language. That one for project. Satu lagi, individual assignment. This is individual. Individual, you need to find one article. Optimization article. Dapatkan ni. First you need to title. Show the title. Description about this article. Okay, and then the mathematical formula of inner function. Nanti detail I bagi slide nanti. Inner function you need to define. Based on this article, you just pick up the inner function and then you need to explain about this what we call the meaning of inner function in detail. Okay, need to describe or need to define the inner function based on that article explanation from the article. You need to rearrange the wording, the inner function, and then the variable involved, and then variable involved. After that, you need to give you need to define the hard constraint and soft constraint. And soft. And then after that, show the result. The individual assignment. Ulang? Clear? Clear ke tak?
Yang result tu result daripada artikel tu sendiri
Yeah. Result daripada artikel. And then give some your comment about this article. Ini penting, very penting. Comment about this article. How do you think?
Maksudnya apa yang kita faham lah.
Yes, apa yang faham. Kalau ada, can give suggestion, improvement. Sometimes you say maybe you need better do like this or better do like that. Macam mana? Up to you. Give some comment lah about this article.
Okay.
Or comment or suggestion. So that one for individual. So stage number 1, week 3, you need to submit this one, and then week 7, I give. We discuss in detail after week 3. The next step for group project. The next step. Okay. After week 3, we discuss for step number 2 for group project. And then we have quiz. Nanti kita ada quiz. So yang tu nantilah lepas cuti semester break. Kita sebulan lagi cuti kan? 4 minggu lagi cuti. Kan kita ada 2 kali cuti semester break kan? This time.
Yeah.
Betul, sir.
Okay. So I think that's all for today. So see you next week.
Sir. Sekejap.
Yeah.
Yang individual project, individual punya assignment ni, bila kena hantar? Week berapa? Cuti juga ke?
Tak ada. Ni actually I tak boleh nak. I boleh set, tapi kalau I set, kalau tak follow tak ada guna juga.
So in our time lah.
Sebab kalau I set katalah week 7 or week 8, you cannot, maksudnya you cannot produce or you cannot deliver. So tapi kalau boleh week 7 tu I nak kena nampak adalah the something that 50% dah siap, macam tu. Week 10 tu dah kira complete, dah boleh submit dah individual. Sebab individual only sekali je. I tak buat 2 kali, I buat sekali je. For individual project ni, I buat 1 je. Tak buat 2 atau 3 kali. Different topic tak ada.
Okay, thank you.
Jadi I nak week 7 tu at least you all dah more than 50% dah ready. Macam tu. More than 50%. At least dah ada, dah tahu the title, dah tahu apa nak guna ni, the description you dah buat, the mathematical formula, how to define, how to explain about the mathematical formula. You need to on your own lah, jangan just copy paste.
So yang apa ni tajuk dia optimization article tu, yang tu kita boleh pilih macam SEO ke apa ke kan?
Up to you.
Oh, okay.
Up to you, sebab kita ada 5 orang kata apa? Big algorithm. So pilih salah satu, either one.
Okay.
Sama juga kalau yang title project ni, for group project. So you can use SEO. Kalau tak nak guna GA, can use PSO pun boleh.
So kalau A-star tu dia termasuk juga ke?
Kalau A-star, okay, I nak tanya, A-star can we put under heuristic ke tak? A-star dia evaluate every single solution kan? Betul tak? Kalau A-star search teknik, katalah you ada solution 100 solution or 1000 solution. So the process will evaluate every single chromosome or every single solution using A-star approach. Betul tak?
Betul.
So A-star we cannot put under heuristic teknik.
Oh, faham.
Tapi GA is a heuristic technique because we evaluate part of total solution. That's why kalau we have big solution, 1000 or million solution, for A-star is not what we call not practical to implement. Tapi kalau less than 1000 solution, so we can use A-star to evaluate.
Okay. Faham. Thank you, sir.
Okay. Okay, so that's all for today. So see you next week. Assalamualaikum.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.